Hello. Yes, we welcome you back to PSSB with me, Richard, here. Okay, this question says that consider the atom below. This is the atom. Okay. And the question says state the number of protons. Okay. Yeah, what's the number of protons here? Okay, you have to know that protons are found inside the nucleus and they are positively charged. So what do? You look inside the nucleus and you do the count. We have 1, 2, 3, 4, 5, 6, 7. So what is the number? 7. Okay. Then the next question comes, state the number of electrons. Where do we see to check for electrons? You look outside the nucleus in these lines, which we call energy levels. And you look for them, they are negatively charged. So electrons are negatively charged and you count them. You say 1, 2, 3, 4, 5, 6, 7. So they are also 7. Okay. Then you come to neutrons. Where do you find neutrons? Inside the nucleus. And how do we identify them? They don't have a charge. So these red dots are the neutrons. So you say 1, 2, 3, 4, 5, 6, 7, 8. So neutrons are 8. Okay, then we come here. It says that what is the atomic number of the element to which this atom belongs? Okay, how do we identify the atomic number of the element? Atomic number is the same as number of protons. So we saw that this atom has 7 protons. So its atomic number is 7. Yeah, then we come to this one. It says that what is the atomic mass of the element to which this atom belongs? Okay, how do we get atomic mass? You have to know that atomic mass is equal to protons plus neutrons. So when we made the count, we found that we have 7 protons and 8 neutrons. This one gives you atomic mass as 15. Yeah, then we come to this question. It says that give a reason why this atom is neutral. Neutral means not having net charge. So we need to know that inside the atoms we have the protons which are positive and the electrons which are negative, but it's neutral. Why do we say it's neutral? The answer is that the number of positive protons is equal to the number of negative electrons. Yeah, then we come to this one. It says, name the force which holds the electrons in position. So when you look at this atomic structure, you would imagine that electrons can move away from the atom, but surprisingly, they stay intact, just orbiting around the nucleus, but within the atom. Now the question is, what force holds those electrons in position? The force is the force of attraction between the protons, which are positive, and the electrons, which are negative. That electrostatic attraction is the one which is holding the electrons in position. Yes, so now we come to this question. It says the atom can lose or gain electrons. Okay. State the charge acquired by the neutral atom under the following changes. Write positive or negative. The first one, when the atom loses electrons. So what charge is acquired by the atom when it loses electron? Or when it loses electrons? The atom becomes positive. Yes, it becomes a positive ion. Okay, then we come to this one. When the atom gains electrons. If it's neutral and gains electron, it becomes what? It becomes negatively charged. So the answer is negative. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences, Silver Bullet with me, Richard here. We urge you to subscribe, to comment, to like, to share. And we also have to remind you that PSSB, or Physical Sciences, Silver Bullet, is a YouTube science channel specializing in physical sciences grade 12, 11, and 10, and natural sciences grade 8 and 9. We advise you that when you're using our channel, use our playlist. Just go to playlist and look for the material which belongs to your level. For grade 8 and 9, look for natural sciences grade 8 or natural sciences grade 9. For grade 11 and 10, look for physical sciences grade 11 or physical sciences grade 10. For grade 12, every chapter is covered independently. So just look for the chapter of your choice and click on it. Then you'll have all the material which you need for that topic. With that, I would like to say thank you. We appreciate your time. Stay blessed. See you next time. Bye bye.